means we're putting back together and we're fixing without parts from Bugatti, and we've already done and accomplished what we were told couldn't be done, which is give us confidence.
What if everything the experts said was impossible wasn't? A Bugatti Chiron Pur Sport, completely wrecked, not scratched, not damaged, but destroyed, sits in a small garage. According to everything we know, a car like this isn't meant to be rebuilt in a small garage. It's meant to be written off, forgotten, or sent back to the people who built it. Yet someone is about to defy them all. Sparks will fly, bolts will snap, and every second could end in disaster. What unfolds next isn't just about a car. It's a challenge to the impossible itself. The world is about to witness a rebuild nobody thought possible. And the stakes have never been higher. The crashed Pur Sport and Bugatti's warning. It all started with a crash that shook the hypercar world. Alex, a fellow creator and friend of Matt Armstrong, owns one of the rarest cars on Earth, a Bugatti Chiron Pur Sport, one of only 60 ever made. The damage was catastrophic. The front end was completely smashed, the aluminum frame bent, and the gearbox badly compromised. Most people would have considered it a write-off, but for Matt, this was an opportunity screaming for defiance. Bugatti immediately got involved. They offered an official repair plan at the factory, a $600 job, but there was one strict condition. The car had to be repaired in one of their 2 authorized facilities. CEO Mate Remick later posted a myth-busting video about the situation. Calm, precise, and serious, Remick warned, there are only 2 places in the world that can do this. It requires specialized equipment and training. He emphasized that trying to rebuild a Chiron Pur Sport outside these facilities could result in catastrophic failure, even life-threatening consequences if the car were ever driven. The video racked up hundreds of thousands of views, making the stakes public and painting Matt as the defiant underdog in a David versus Goliath scenario. Matt didn't hesitate. He saw what others couldn't, the chance to push limits, test skill, and prove that independent workshops could tackle what factories claimed was impossible. Negotiating a buyback for $1.9 million, he took possession of the wreck, ready to davy the narrative. This wasn't just a stunt anymore, it was a high-stakes mission. Every decision could lead to financial ruin, reputational fallout, or total failure. But backing down wasn't in Matt's DNA. The garage quickly became a battlefield. Matt and his team started dissecting the Pur Sport, documenting every bend, crack, and broken mount. The public watched closely, some skeptical, some cheering the audacity. Every frame inspection, every weld test, every "oh no" moment was magnified under the scrutiny of Bugatti enthusiasts and hypercar fans worldwide. Social media was full of debate. Could Matt really split a Chiron, reinforce catastrophic damage, and safely bring it back to life in a regular workshop? Or would he prove the factory's warnings right and create a total disaster? Emotionally, the project had everything. At first, people called it a stunt, doubting it could succeed. But with each teardown, Matt's determination became clearer. The tension built as the team faced structural failures, snapped bolts, and decisions that could make or break the car. From skepticism to high-stakes defiance, the narrative unfolded in real time, and the world began to realize that this wasn't just a repair. It was a challenge to the very limits of what independent builders could achieve. Matt's mindset set the tone: fearless, meticulous, and relentless. Every move in the garage was a calculated risk. Yet each small victory, the inspection of a bent mount, the welding test, the first partial reassembly, was a triumph against the odds. By the end of this chapter of the story, the Chiron wasn't just a wrecked car anymore. It was the symbol of a defiant garage revolution. Splitting the Chiron. The first real test was splitting the Chiron in half. Bugatti had warned this was impossible outside their factories. Only 2 facilities worldwide were supposed to handle this, using specialized lifts and tools. Matt Armstrong's garage? Nothing fancy, just basic lifts, hand tools, and a team ready to defy expectations. The goal was simple in theory: separate the front and rear sections to access the engine and gearbox. In practice, every step was a minefield. The team started with careful disconnection of wiring harnesses, fluid lines, and structural mounts. Every cable and pipe had to be accounted for. Every bolt inspected. Oh no! Moments arrived quickly. Hidden fasteners appeared in unexpected places. Corrosion on brackets threatened progress. And the carbon fiber tub revealed surprises that could easily ruin the alignment. Each discovery was met with focused problem-solving. Matt called out measurements, double-checked torque specs, and kept morale high despite the pressure. What made this phase extraordinary wasn't just the danger or complexity, it was the speed. Bugatti claimed the split required weeks in a controlled factory setting. Matt's team completed it in days. Watching the halves lift apart was jaw-dropping. Clean, precise, and shockingly efficient. On camera, Matt grinned, saying, "Today, we need to make sure there are 3." Pointing to the neatly separated halves sitting side by side in the workshop. It was both a literal and symbolic victory. Proof that factory exclusivity could be challenged with skill, determination, and creativity. Technically, the split required extreme attention to detail. Fluid lines for coolant, oil, and brake systems had to be drained and sealed, wiring carefully labeled to prevent shorts or misfires. Engine mounts and subframe bolts were removed in a precise sequence to avoid bending the chassis or damaging components worth millions. Even small missteps could have catastrophic consequences. One wrong move could snap the carbon fiber tub, crack the aluminum mounts, or worse, make the car undrivable. Every connection and disconnection was double-checked, filmed for documentation, and analyzed by Matt's team in real time. Emotionally, this stage was massive. The internet watched, skeptics doubted, and the tension was palpable. Each "oh no" moment became a mini cliffhanger. Every bolt that turned without issue was a triumph, and every minor setback built anticipation for the next challenge. By the end of the split, Matt had done more than separate 2 halves of a hypercar. He had challenged the narrative of impossibility that Bugatti had set, setting the tone for the entire rebuild. This achievement sent shockwaves through the car world. Catastrophic damage revealed. With the Chiron split, the full extent of the crash damage became impossible to ignore. The engine had been shoved forward during impact, crushing the coolant pipe and twisting connections that were never meant to move. The cast aluminum engine and gearbox mount, the very backbone holding the powertrain, was broken on both sides. Clean fractures ran across the mount like scars, showing just how violent the impact had been. Matt looked at the damage and said on camera, "The team got to work carefully inspecting every component. Every bolt, every bracket, every fluid line was examined. The good news? The deeper engine block remained intact. No pistons were cracked. No cylinder heads were shattered, and the internal gearbox components appeared untouched. That meant the core of the car, the part that makes the Chiron a Chiron, was still usable, but the mounts were critical. Without a functioning engine and gearbox mount, nothing else could be reassembled safely. A tiny mistake here could ruin weeks of work or even render the car undrivable. Matt's attention to detail became obvious in these moments. The team measured the fractures, checked alignment, and planned how to reinforce or replace each broken section. Every decision mattered. They couldn't rely on Bugatti's factory, and there were no ready-made solutions. Each broken mount meant a new challenge. Figuring out how to weld, reinforce, or fabricate something stronger than the original without causing further damage. The risk was enormous, and one slip could undo all progress. Emotionally, this stage was intense. The initial dread of seeing the catastrophic damage gave way to determination. Matt's energy shifted from tension to focus. Cameras captured his reactions, slow exhalations, studying blueprints, nodding to his team. Each inspection point became a small victory. Recognizing that the damage was contained was a relief. But the gravity of the mounting repair was never far from anyone's mind. This moment highlighted why Bugatti insisted on its 2 authorized facilities. The company wasn't trying to be difficult. It knew the structural damage, the precision required, and the risks involved were beyond normal workshops. But Matt's response was consistent with his defiant approach. That mindset turned what could have been a stopping point into a rallying moment. The catastrophic damage wasn't just a setback. It was the stage for one of the most technically daring and high-stakes parts of the entire rebuild: the weldability test and reinforcement. With the catastrophic mount fractures revealed, the next challenge was clear. Could the broken cast aluminum engine and gearbox mount be repaired safely? Aluminum is notoriously tricky to weld. Too much heat, and it cracks. Too little, and the bond fails. The team began with a weldability test. Carefully applying controlled heat to a sample section, they confirmed the metal could be fused without risk. Relief swept through the garage. This was the green light to move forward. The stakes remained sky-high. If the mount failed again during welding, weeks of progress could vanish in an instant. Enter Bob, Matt Armstrong's most trusted fabricator. Every hypercar rebuild requires someone who understands both the material and the pressure. Bob's experience and steady hands became the linchpin of the operation. He began by carefully welding the clean fractures, joining the broken cast aluminum with precision. Sparks flew, metal glowed, and each weld was scrutinized for perfection. Matt and the team watched every angle, ready to catch the smallest flaw. Welding alone wasn't enough. Matt insisted on reinforcement. Using extra aluminum bracing and a precise welding pattern, Bob strengthened the mount beyond the original cast design. The goal was simple, not only to repair it, but to make it stronger than factory specifications. Every angle, every connection was tested with measurements and stress simulations. Matt documented it all: camera angles showing before and after comparisons, close-ups of weld beads, and footage of the reinforcement process. This was not just a repair, it was an engineering evolution. Even in the best-planned operations, setbacks happen. While tightening one of the mount bolts, a snap echoed through the garage. Incorrect torque had caused the fastener to fail. A brief pause, a replacement bolt, and careful retorque later, the mount was back on track. Matt's team didn't panic. They knew these hiccups were part of the process. Matt later commented in a voiceover, "Each challenge reinforced their resolve." With the mount repaired and reinforced, the team reassembled the components. Alignment was checked multiple times, connections double verified, and every weld inspected. The Chiron was no longer just a wreck. It was a symbol of ingenuity and determination. The internet watched every moment, comments pouring in, disbelief, awe, and excitement at the audacity of doing what Bugatti claimed could only be done in 2 facilities worldwide. Reassembly and first engine start. After weeks of disassembly, welding, and reinforcement, it was finally time for reassembly. Matt Armstrong and his team began reconnecting everything: wiring harnesses, fluid lines, and the custom Valvetronic exhaust upgrade. Every connection mattered. A missed wire or misaligned line could ruin the engine or cause a catastrophic failure. The team moved carefully but efficiently, double-checking each step, measuring torque values, and documenting progress for transparency. This wasn't just putting a car back together, it was reconstructing a hypercar in a garage where no one had expected it to survive. Once all systems were connected, the moment of truth arrived. Matt climbed into the driver's seat, took a deep breath, and pressed the ignition button. Instantly, the W12 roared to life. Sparks of excitement and tension filled the garage. The engine idled perfectly, vibrations steady, fluids flowing, electronics responding as they should. Without skipping a beat, he shifted the car into gear. The transmission engaged smoothly. The Chiron wasn't just repaired, it was fully functional. This milestone was bigger than anyone expected. Bugatti had publicly claimed the repair could only be done in 2 authorized facilities worldwide. Independent garages, according to them, didn't have the tools, experience, or authority to attempt such a rebuild. Yet, here Matt was, proving otherwise. The achievement wasn't simply about starting the engine, it was a functional proof that a wrecked Pur Sport could survive complete disassembly, catastrophic mount failure, welding, reinforcement, and reassembly, all outside the factory environment. The implications were huge. The reaction was immediate. The video documenting the first engine start racked up millions of views almost overnight. Comments poured in: disbelief, awe, and admiration for the meticulous attention to detail. Emotionally, the moment was electric. After weeks of tension, oh no, setbacks, and painstaking work, the sound of the engine confirmed that their planning, skill, and courage had paid off. Every reinforced mount, every welded fracture, every snapped bolt replaced, each small victory led to this defining moment. Matt's grin wasn't just about the car starting, it was about proving that persistence, trust in the team, and fearless determination could overturn decades of hypercar exclusivity. Ongoing risks. Even after the Chiron Pur Sport roared to life, the project was far from finished. Success in the engine start marked a milestone, but the rebuild carried ongoing risks that demanded constant attention. The cooling system remained a major concern. Early test drives had been done without coolant in place, and even brief operation under those conditions could have caused serious engine damage. Matt's team monitored temperatures carefully, ensuring no heat spikes or leaks threatened the W12. Any oversight here could undo weeks of meticulous work. Front-end structural damage also posed a lingering challenge. The crash had bent aluminum supports and twisted suspension points. While the engine and gearbox were secured, these compromised areas could affect handling, alignment, and safety under high-speed operation. Every inspection required precise measurements and repeated testing to guarantee the chassis could bear normal and extreme driving stresses. The team reinforced critical points where factory-grade components had been damaged, but even with reinforcements, subtle stress points remained. Long-term reliability was another consideration. Modern hypercars like the Chiron rely heavily on electronics, sensors, and integrated systems for engine management, traction control, and gearbox operation. Any misconnection, vibration, or alignment issue could trigger failures. Matt's team spent hours testing sensors, verifying ECU signals, and checking for anomalies. The electronic systems had to synchronize perfectly with the rebuilt mechanical components, which required patience and exacting standards. A small oversight in wiring or sensor calibration could render the car unsafe or undrivable. One detail that raised curiosity was the starter motor. The rebuild used a unit sourced from a Volkswagen Polo 1.9 TDI, a humble engine part adapted to work in the W12. This choice highlighted both resourcefulness and risk. While it functioned as intended, it underscored the unconventional methods the team employed to achieve a rebuild outside the factory. Every adapted component required careful testing to ensure compatibility and durability. The project had shifted in perception. Initially, the Chiron rebuild was seen by many as a daring stunt, a demonstration of garage skills and audacity. With the first engine start and functional testing complete, the focus moved toward proving true functionality and long-term reliability. Each measurement, reinforcement, and system test turned the project from spectacle into technical proof. The garage had become a demonstration site, showing that independent workshops could tackle components previously reserved for factories. Despite the excitement and public attention, the team understood the stakes. The car was operational, but it remained far from fully roadworthy. Every drive had to be carefully monitored, every stress point inspected. The work so far had proven the possibility, but the lingering risks emphasized that rebuilding a hypercar outside a factory was not a casual project. It demanded discipline, skill, and constant vigilance. Matt Armstrong's rebuild of the Chiron Pur Sport didn't just make headlines, it set off a global movement. Workshops across Europe, Asia, and the US began studying his techniques, from precise welding of cast aluminum mounts to creative aftermarket solutions and 3D printed components. Independent builders, once sidelined by factory-only restrictions, now saw a path forward. The methods Matt pioneered were being adapted, refined, and applied to other hypercars, turning a single garage project into a blueprint for a worldwide network of high-stakes rebuilders. The broader impact went beyond skill sharing. Matt's project became a symbol in the 2026 Right to Repair movement for hypercars. EU and UK petitions, citing his rebuild as precedent, have already surpassed 50 signatures, demanding that manufacturers stop blacklisting VYNs and denying parts to independent workshops. Where once a wrecked hypercar meant only factory intervention, now the conversation shifted. Independent repair was not only possible, it was a matter of consumer rights. What began as one man challenging Bugatti's exclusivity evolved into an industry-wide reckoning. Matt's defiance demonstrated that technical skill, careful planning, and ingenuity could circumvent long-held barriers in the exotic car world. Workshops across the globe now feel empowered to test limits, innovate, and challenge manufacturer monopolies on repair access. The Garage Revolution arc is about more than cars. It's about a shift in mindset. The narrative has moved from stunt and spectacle to practical proof and collective action. Matt's rebuild is now cited in forums, online groups, and technical communities as a tangible example of what's possible when independent engineers refuse to accept restrictions. His work has inspired new collaborations, cross-border workshops, and a culture where ingenuity, not factory permission, drives progress. Matt Armstrong just rewrote the rules of hypercar repair, turning a wrecked Chiron into a global inspiration. The Garage Revolution is here, proving that impossible isn't permanent. If you want more jaw-dropping rebuilds and behind-the-scenes engineering drama, hit like, subscribe, and turn on notifications. You won't want to miss what's next.